also uploaded the recording stream for the tree-based methods. Okay, so if you want to go back, we saw that about classification trees. You all remember the Haynes data set. I think Sophia was also using this data set I tried to use one of these few of these algorithms on the Haynes data set, and this is basically to import the data. And once you import the data, we need to change the gender and group that are imported as an integer and stuff like that to factors. Okay, so that's what I did here, and then you can see that the data frame is now ready for processing. Okay, so there is in data science you have lots of neat ways to visualize the data and also look. There is a very good package that has been developed. It's called Tidyverse. So who took my class previous in fall would know about this package called Tibble, and that's a modern way of looking at the data in a very nicer way. It throws out all the unnecessary things and it makes into a very nice form. So I mean, this is just for aesthetic purposes. It's not really you don't have to sweat it out on any of these things. But what we noticed is that when you take there are several variables here. This is Haynes is one of the New York Nutrition Health and Examination Survey data set, and there are about 26 lots of features in here, and one of the feature is a hemoglobin content and also the urine albumin creatine ratio. When you do that, you see two clusters in here. Okay, so and initially I thought these two clusters were people with diabetes and people without diabetes, but when you label them, you see that the people with diabetes, red, and the people who have diabetes but not diagnosed, they form into a big separate spectrum. And so these two clusters are essentially people who are not having any diabetes. Okay, you still have these two clusters. So I wanted to see if we can apply classification and see the trees that can distinguish these two clusters. Okay, so I made this data set. Here what I'm trying to do is that I'm trying to separate these two clusters, and then I'm labeling it as low UACR and high UACR. If it is less than -2, this cluster, -2, if the log of UACR is less than -2, it is low UACR, and if it is greater than -2, it's high UACR. Okay, so I'm labeling these, and then I'm removing all the unnecessary things like key, gender, and stuff like that, and I'm just using these labels, and here I'm like changing the labels so that it is easy for me to visualize the tree. Okay, so that's what this code does, and then I'm trying to use the tree algorithm. Okay, so that's given by this tree function, and when you load the library, and then you can separate it as factor, and then you can construct the tree, right? And you can use what is known as a summary. Almost all functions have this summary, and you can look at the classification tree here. It just used 4 variables: mercury, urine, LDE, LDL estimate, mercury total blood, creatinine, SI, and then cadmium. And then it's trying to construct the tree here, and you see that the misclassification error is nothing but this number of nodes. The total misclassification error is given by this formula. For the classification, the reported deviance is given by this formula. So it is used. We can see that the training error is about 12%. Okay, and the plot tree, it can immediately give you a tree, and you can write the text, and you can immediately see the tree. That's one good thing about classification tree, is that you can interpret the tree, right? And we should technically use the test error, right? Once you construct the tree, you have to see. So this is general tree, right, without all these things. But what I did was I took 700 data points. There were about 1,200 data points. I took these into 2 data sets, one for training and the other for testing. And I ran this, and then we saw that it's about 83%. Okay, so but now we can see that the tree, it's a general tree that's constructed, so you can prune the tree, right? You can make the minimal number of nodes, and then for that you can use cv.tree function, and if we use that, we can see the mean deviance, right? For the cross validation, as the data, the nodes increases, you will see that it is reaching the minimum, the peak is here. So with this two information, now I will be able to construct the tree better, and with that, the best 6 number of the leaf nodes, when I do that, it gives a much different tree here, okay, and the classification accuracy is about 87%. So this is a general way of going about and using the tree based method. So you use a cross validation to find the optimal number of nodes the tree should have, and then you construct the tree, okay. So this is one of the examples how to go about in using classification trees, right, for your data set, how to go about in finding an optimal tree for your data set, okay. So you can try similar things with your own methods. I mean, the code is pretty simple. All you need to do is change this to your data set, and you can run through this pipeline, okay, so that you can follow that, okay. And also I will briefly show you